Hello guys, the next important question from chapter 4 motion in plane is show that the trajectory of object thrown at certain angle with the horizontal is parabola. So for that, consider a projectile projected upwards, right? X-axis, y-axis. So in such a way, right? Projected in upwards. What happens? It reaches to maximum height and again return back to the earth. Right? Okay. It reaches to maximum height. Let h be maximum height. It reaches to maximum height and again return back to the ground. Next, let consider u as initial velocity. Okay, you throwed projectile in upward direction. No, u as initial velocity. Right? Resolve u into two components. Right? First one, horizontal component. What we will write? U cos theta along x-axis. Next, vertical component u sin theta along y-axis. And this complete distance means from the place where you thrown the projectile, again the projectile after going to maximum height returning back and falling on the ground, that complete distance covered by the projectile we call it as range. Let R be the range. Okay. Now let this distance denote by y and this distance with x itself only. Now first let us find the motion along horizontal. Very easy topic but most important. Motion along horizontal or horizontal motion. If you want, you can keep a side heading like that also. Horizontal motion. So what is horizontal component? Ux is equal to u cos theta. Alright? Ux is equal to u cos theta. So first let us write the distance travelled along by projectile along OX. Here you place O, no? OX in time t. What is the formula for distance travelled? Instead of R, I am keeping X. Total distance travelled X. What will be the formula? Velocity means what? Distance by time, no? Displacement by time. So distance becomes velocity into time, no? Following this only. So no need of writing in exam, just for your idea. So it is horizontal velocity component. Horizontal velocity along x-axis we are taking. No, here if you want I will write along x-axis. We are considering along x-axis. Horizontal motion, no? Horizontal velocity component into time. Right? What is horizontal component of velocity? U cos theta. Time you assume as t. From this t I can write as x by u cos theta. Put it as equation 1. 50% of answer is completed. Very easy. Don't confuse. Now, vertical motion or motion along vertical. Vertical motion will be along y-axis. Along y-axis. Vertical motion will be along y-axis. Right? So now, the distance traveled along OY in time t. What I have to write? I'm using S is equal to UT plus half AT square formula. Right? Now, what I will write? In place of S, put in place of S, vertical motion I'm considering as Y. Right? In place of U, what you have to place? Vertical velocity. That is U sine theta. Right? In place of A, I projected in upward direction. No. So it becomes minus G. Now in place of T, here we find it. No. X by U cos theta. I'm substituting all this here. So now I'm writing this afterwards. Here let us write. Now distance traveled along OY in time t. So substitute here y equal to what is u? U sine theta. What is t? X by u cos theta. What is a? Minus g. What is t? X by u cos theta whole square. U strikes off. What here? Sin theta in numerator, cos theta in denominator, and x remained. Minus is there, so minus g. Here 2 is there in denominator. Whole square is there, so x square by u square cos square theta. Sin by cos, tan theta. Minus, just how I am writing means g by 2 u square cos square theta x square. Now, in place of tan theta, put a. In place of this bracket term g by 2 u square cos square theta, put b. Okay, put in place a in place of tan theta and b in place of g by 2 u square cos square theta. Right? Now, this is parabola equation. This is equation of parabola. So hence path is parabolic, hence proved. What he said? He said to show that trajectory means what? Path. Path of object thrown at a certain angle with horizontal is parabola. We proved. Okay. Thank you for watching my video. Stay with my channel to receive the next important questions of chapter 4, motion in plane. So thank you for watching my video. Thank you.